Hello everyone, my name is Nandita and now I'm going to present on embedded systems. Embedded system is a microprocessor based system that does not look like a computer. 80% of the embedded system's actions are based on a microprocessors. What are embedded systems? An embedded system is an electromechanical system designed to perform a specific function. It is a combination of hardware and software. It consists of three components, mainly hardware component, software component and mechanical component. It is supposed to do only one specific task. This is the picture of a general embedded system. What are the elements of embedded systems? An embedded system is a combination of three things: hardware, software, and mechanical components. And it is supposed to do one specific task only. A typical embedded system contains a single chip controller which acts as the master brain of the system. Embedded systems are basically designed to regulate a physical variable such as microwave oven or to manipulate the state of some devices by sending some signals to the actuators or devices connected to the output port system, such as temperature in air conditioner, in response to the input signal provided by the end users or sensors which are connected to the input ports. Hence, the embedded systems can be viewed as a reactive system. This is the picture of an embedded system. It contains six parts. Mainly, the main part of an embedded system is a system core, which is also a microprocessor or a controller like FPGA or ASIC or DSP or SoC. We will come to know about these in the further slides. Now, for the memory, we use embedded firmware, and for the communication interface, we use USB drives or 9-pin cables. For the output ports, we have actuators, and the other supporting integrated circuits and systems are interconnected to a system core. For the input ports, we have sensors. And for example, in an air conditioner, the sensors sense the temperature of the surrounding and they compress or stimulate the ACs. Moving to the next slide, we have the core of an embedded system. The core of the embedded system falls into any one of the following categories: the general purpose and domain specific processors, microprocessors, microcontrollers, digital signal processors, programmable logic devices, application specific integrated circuits, commercial off the shelf components. So these are the core of an embedded system. Mainly, an embedded system is a combination of microprocessor and a microcontroller. It is very different from a general purpose computing system. Let us know what is an embedded system with the help of an example. Here, for example 1, we have a washing machine. A washing machine from an embedded system's point of view has a hardware which contains buttons, displays and buzzer or an electronic circuitry. And for software, it has a chip on the circuit that holds the software which drives the controls and monitors various operations possible. For the mechanical components, the internals of a washing machine which actually wash the clothes and the input and the output of the water. To know more about the embedded system, let's take another example of an air conditioner. An air conditioner, from an embedded system's point of view, has a hardware, software, and a mechanical components. So, what are the hardware components that are present in an air conditioner? Remote, display and buzzer, infrared sensors, or electronic circuitry. For the software, it has a chip on the circuit that holds the software which drives control and monitors the various operations possible. The software monitors the external temperature through the sensors and then releases the coolant or suppresses it. For the mechanical components, the internals of an air conditioner, the motor, the outlet, etc. For the let's know the difference between the general purpose purpose computing system and the embedded system. So based on the criteria, we have differentiated general purpose computing system to the embedded system. On the criteria of the contents, the system which is a combination of generic hardware and general purpose operating system for executing a variety of applications. A system which is a combination of specific purpose hardware and embedded OS for executing a variety of applications is called an embedded system. Based on the operating system criteria, the general purpose computing system contains a general purpose operating system or simply GPOS. For an embedded system, it may or may not contain an operating system for functioning. For the power consumption, the general purpose computing system consumes more power compared to embedded system. But according to the criteria of the power consumption, embedded system always consumes less power. According to the response time, here the general purpose computing system is not critical, whereas the embedded system is critical for some appliances. Criteria of execution, the general purpose computing system need not to be deterministic, whereas the embedded system is to be deterministic for certain types of ES like hard real-time systems. On the criteria of key factor, we have the performance of the general purpose computing system is the key deciding factor in the selection of the system. The faster is the better. Whereas an embedded system application specific requirements are the key deciding factors like performance, power requirements or memory usage. This is the basic difference between a general purpose computing system and an embedded system. So, this is the differences between a general purpose computing system and an embedded system. Moving to the next slide, we have the classification of embedded systems. Basically, the embedded system is divided or classified based on these four criteria. That is, on generation, on complexity and performance, on deterministic behavior, and on triggering. So, the embedded systems that we see today are the classifications that are based on generation. So, detailing on generation, we have the first generation or 1G. They are built around an 8-bit microprocessor and a microcontroller. They are simple in hardware circuit and firmware developed. The examples are digital telephone keypads. The second generation or 2G. They are built around 16-bit microprocessor and a 8-bit microcontroller. And they are more complex and powerful than 1G microprocessor and a microcontroller. Examples for second generation is SCADA systems. For the third generation, they are built around a 32-bit microprocessor and a 16-bit microcontroller. The concepts like digital signal processors, application-specific integrated circuits are evolved. The examples for third generation is robotics or media, etc. The fourth generation is what the embedded systems that we use today. They are built around a 64-bit microprocessor and a 32-bit microcontroller. The concept of system on chips or SoC, multi-core processors evolved. Highly complex and very powerful. The examples are smartphones, fitness bands, etc. Now, let us know the application of embedded systems. The embedded systems are used in consumer electronics like cameras, fitness bands, etc. They are also used in home appliances like in washing machine, air conditioner, nowadays in rice cooker and electric stoves. They are used in security systems like fire alarms and also in the home heating system. They are used in automotive industry, also in telecom industry and in computer peripherals and mainly in computer networking systems to connect to connect the data connections between the smartphones and also they are used in the optic fiber materials. Finally and mainly in the healthcare as they are used to check the pulse rate, heart rate or ECG of a patient. This is all about the embedded systems. Here we have come to know about what are embedded systems and what are the elements of the embedded systems, the core which is based on the embedded systems, and also the classifications of embedded system, the difference that we know about between a general purpose computing system and an embedded system, and finally the application. So this is all about the embedded systems. Thank you.